Hi, I'm Lucy, and in this video we're going to look at surds. But what on earth are surds? A surd is a square root which cannot be reduced to a whole number. What does that even mean? Let's have a look at an example. So square root 25 and square root 9/16 are not surds because even though they are inside a square root sign, they can be evaluated. We can simplify them. Whereas, for example, square root 2 and square root 3 cannot be simplified. They are irrational. If you type them into your calculator, you get lots of decimal places that carry on forever, and the numbers cannot be written as fractions. So have a look at this table. See which are surds and which aren't. Surds are actually really useful. See how much easier it is to write square root 2 rather than all of those decimals. And actually, in Pythagoras, we come across them a lot because it is much more accurate to leave it as a surd than to round the decimal places. So square root 1044, or the simplified surd form of 6 root 29, is much more accurate and easier than writing 31.31, etc. So not all square roots are surds, but all surds are square roots. Let's have a look at simplifying surds. 6 root 29 is the simplified version of square root 1044. But we'll start with much simpler examples. Have a look at these simplified surds. How have they been simplified? Can you spot what is happening in the working column? How the working connects to the original surd? Pause the video, have a think, and click play when you're ready. Did you notice how when doing the working, we look for a square number that goes into each surd, and then what it multiplies by? So root 4 is the square number, multiplied by 2 makes 8. Again, root 4 is the square number, multiplied by 3 makes 12. In this one, root 9 is the square number, multiplied by 3 makes 27. It could be any square number, 16, 25, 36, 49. Make sure you know your square numbers. Just a quick thing though, root 180, I wouldn't necessarily know that 36 goes into it, but I do know that 9 does. So I could start by simplifying it to root 9 multiplied by root 20, and root 20 isn't fully simplified, so we just keep going. 3 root 4 root 5 and all the way down to 6 root 5. So give these questions a go. Pause the video, work out the answers and click play when you're ready to check. Did you get them right? If not, just make sure that you simplified them fully until no more square numbers factor into them. So that is the beginning of surds. We now know what they are and how to simplify them. In the next video, we're going to look at how to multiply and divide with surds, and then also how to add and subtract with them.